I have my given down, listed the different theorems that we can use to do what they're asking, which is prove the triangle's congruent. Each one of those 4 reasons I have up there, those abbreviations are for sets of corresponding congruent angles or sides. We need corresponding congruent angles or sides. Well, let's look at what they gave us. AD and CB, as I highlight them here, are parallel, so I could put some marks there. Doesn't mean they have to be congruent. A lot of times kids will say, well, then those two are congruent. Not necessarily true. We just know they're parallel. Usually you're looking for specific type of angles that would be congruent. Then like here, angle A is congruent to angle C if you'd like. So angle A, oops, that's not our reason, that's our statement. So put it over here, angle A congruent to angle C by the alternate interior angle theorem. Now last time I did this, I've done it a couple different ways. I actually used both sets of alternate interior angles. So you could say D and B. I think I'll do that again, but I've also done it before just to show you that you can use your vertical angles. Now there's no reason to have 3 sets of angles though, because when you're looking at what what reasons we have, the most we ever use is 2. So if I wanted to say angle D congruent to angle B, that would work out just as well. It just depends if you notice. Otherwise, maybe you notice the vertical angles, you could get your second set of angles that way. Might make a difference in what reason you use in the end, but still, either one would be okay. Just to make sure I know if I use angle, angle, side, or angle, side, angle when we get done, to make it really obvious, I'm gonna kind of highlight one of these triangles. I'm gonna go ahead and angle those, or label those 2 sets of angles from one triangle to the next. So when I'm done, I can see if I have the side in between, or maybe the non-included side, the side not in between. Alright, gotta have at least one side though. The vertical angles aren't gonna finish it up. What else do they give me? M is the midpoint of AC. It doesn't mean everything is the same that, kind of is formed by M. It's not the midpoint of DM. It doesn't say that. It could be, but it doesn't say that. So I'm going to highlight, it's the midpoint of A to C. So there's A, there's C, M is right in the middle. What's going to be true? Well, by definition of being in the middle, both values, like from A to M and from C to M, would be the same. We actually have a theorem for that, the midpoint theorem, that's gone ahead and proved that those values could be changed and stated congruent. I want congruent parts. We need sets of corresponding congruent parts. So I'm going to use the theorem to say this quicker, which allows me to say that segment A to M, which I guess I've covered that up, the A's down here, but from A to M would be congruent to, and maybe I'll pause and make sure I get this named right, which point corresponds with A. This is a rotation. So if you rotate A around, it's going to end up where C is. So it corresponds with C. M, well, even if it's rotated, M stays in the middle. So we'll just say M is going to correspond with itself. That's named correctly. That's a set of sides. I'm going to label it in my picture, congruent. Also put that S there so I can see. I got 2 to choose from. A couple angles. Just trying to figure out, is the S in between the 2 A's, or is it the non-included side? And because we've taken the time, and I know it seems a little basic, but because we've taken the time to go through and put the A and the S kind of on one of those triangles, it's very clear to see it's not the side in between the 2 angles. So that means we'd be justifying this by angle, angle, side. 2 angles and their non-included side to be able to make the statement that triangle CBM is congruent to triangle ADM. Not the only way to do the proof, but this will work.